In this video, we're going to complete the KutaSoftware Infinite Algebra 2 free worksheet, matrix multiplication. Our instructions for this first part of the worksheet are to simplify, and we're to write undefined for expressions that are undefined. But when multiplying matrices, what would give us something that's undefined? Well, in order to multiply a matrix by another matrix, the first matrix times the second matrix, the number of columns in the first matrix has to match the number of rows in the second matrix. That's the only way we'd be able to multiply matrices together. Otherwise, we write undefined. So let me clarify that a little bit more in number 1. In number 1, we have, let's count, 2 rows by 2 columns. So our matrix in number 1 is a 2 by 2, and the next matrix that it's being multiplied by is 2 rows by 2 columns. So this is a 2 by 2. Now, the neat thing about multiplying matrices, again, I said the columns of the first matrix, the number of columns of the first matrix have to match the number of rows of the second matrix. And 2 does indeed match 2, so we can multiply these. And the neat thing about matrices, when multiplying, remember, we said that in order to multiply, the columns of the first matrix, the number of columns, has to match the number of rows in the second matrix. And the resulting matrix will be the size 2 by 2 for the number of rows in the first by the number of columns in the second. So because we have a 2 by 2 by a 2 by 2, we can multiply because the columns of the first and the rows of the second match, and we know it's going to be a 2 by 2 size because the rows in the first are 2 and the columns in the second are 2. So how exactly do we multiply matrices? And how we multiply matrices is we're just going to do the dot product. And if you don't know exactly what the dot product is, don't worry because it's simple and I'll walk you through it. So remember, I said our result was going to be a 2 by 2, but in order to multiply matrices, we're going to look at the first row, and we're going to dot it, or do the dot product of that and the first column. First row dotted with the first column will give us row 1, column 1 in our resulting matrix. So now let's go over the dot product. We're just going to take our first number in the row that we're on and the first number in our column and multiply those together. So we'll have 0 times 6, and then we'll add that to the second number in our row times by the second number in our column. So we're going to add that by 2 times 3. And that's the result of our first row, first column. Now we're going to keep working with the same row, 0, 2, but now we're going to dot it with the second column. So the first row dotted with the second column will give us row 1, column 2's number. So we're going to do first number in the row times the first number in the column. So that's going to be 0 times -6. And we're going to add that to second number in the row times the second number in the column. That's going to be 2 times 0. Now we have the first row of our resulting matrix complete. Now we're just going to work on figuring out that second row. And we're going to be using the second row of our first matrix. So we're going to dot the second row of our first matrix with column 1 to get row 2, column 1. So -2 times a +6. And we'll add that to -5 times 3, the second number in our row by the second number in our column. Now we'll move on, doing the second row dotted with the second column. That will give us row 2, column 2's entry or element. So we're going to do -2 times a -6, and that will get added to the second entry in the row and the second entry in the column, -5 times 0. Now we can go ahead and simplify this 2 by 2 matrix because 0 times 6 is 0, plus 2 times 3 is 0 plus 6, which is 6. And then 0 times negative 6 is 0, plus 2 times 0 is 0. Then negative 2 times 6 is a negative 12, plus a negative 15 is going to result in a negative 27. And then negative 2 times negative 6 is a positive 12, plus negative 5 times 0 is just positive 12. So my solution in number 1 is 6, 0, negative 27, 12. Let's move on to number 2. The first question we should ask ourselves is, can we multiply this? So let's check. In the first matrix, we have a 2 by 1 because we have 2 rows and 1 column. And in the second matrix, we have a 1 by 2 because we have 1 row and 2 columns. So because the number of columns in the first match the number of rows in the second matrix that we're multiplying, 1 equals 1, then we can go ahead and multiply these matrices. And the result, well, is going to be a 2 by 2. Because remember, for the result, we look at the rows of the first by the columns of the second. So I know my result's going to be a 2 by 2. Let's go ahead and do out the math. So in row 1, column 1, I'm going to take my row 1 of my first matrix, which is just the number 6, and I'm going to dot that with the number in my first column for row 1, column 1's entry. So that's going to be 6 times negative 5. Now that I've done row 1, column 1, I'll do row 1, column 2. So that'll be 6 times 4. And then, now that I've finished my row 1, I'll move on to my row 2. So that's going to be row 2, column 1, negative 3 times negative 5. And then I'll do row 2 to column 2, which will be negative 3 times 4. Now, finishing this out, 6 times negative 5 is negative 30. 6 times 4 is 24. Negative 3 times negative 5 is a positive 15, and negative 3 times 4 is a negative 12. And that's my solution in number 2, negative 30, 24, 15, negative 12. Moving on to number 3, let's see if I can multiply these. I have a 2 by 2 by a 2 by 2. The number of columns in my first matrix match the number of rows in my second, so I can indeed multiply these, and the result is going to be a 2 by 2. So I'll start with row 1 and find the dot product of that and column 1 to get the entry in row 1, column 1. So I'll have negative 5 times the negative 2, and I'll add that to negative 5 times 3. Now I'll do my first row, second column, negative 5 times negative 3, plus, because we're going to add, negative 5 times 5. So I've completed my first row. Now I'll move on to my second row. Negative 1, 2, I'll dot that first with my first column, negative 2, 3. So I'll have negative 1 times negative 2, doing the first numbers in each, and then I'll add that to multiplying the second numbers, 2 and 3. Now I'll do second row, second column to get that entry. So multiplying the first numbers together, negative 1 times a negative 3, and then adding that to the second numbers multiplied together, 2 and 5. So let's go ahead and write this matrix out. I have 5 times negative 2, which is a positive 10, and I'm adding that to negative 5 times 3, which is a negative 15. So that will result in a negative 5. And then I have negative 5 times negative 3, which is a positive 15, but I'm adding that to a negative 25, so that's going to be a negative 10. And then I have negative 1 times negative 2, which is going to be a positive 2, and I'm adding that to 2 times 3, which is 6, so 2 plus 6 is 8, and then lastly, negative 1 times negative 3 is a positive 3, and I'm adding that to 2 times 5, which is 10. 3 plus 10 gives me 13. So my solution in number 3 is negative 5, negative 10, 8, 13. Let's move on to number 4. In number 4, can I multiply them? Yes, because it's a 2 by 2 multiplied by a 2 by 2. My number of columns in my first matrix matches the number of rows in my second matrix that I'm multiplying by. And the result's going to be 2 by 2. So now, starting with the first row and first column, I'll do negative 3 times 6 plus 5 times 1. Now, I'll do the first row, second column, to get negative 3 times negative 2 plus 5 times negative 5. So that wraps up my first row. Now I'll work on my resulting matrices second row. So dotting that with the first column, negative 2 times 6 plus 1 times 1, and then for the second row, second column, negative 2 times negative 2 plus 1 times negative 5. Now to simplifying. Negative 3 times 6 plus 5 times 1 is negative 18 plus 5, which is a negative 13. Next, I have negative 6 times negative 2 plus 5 times negative 5, which is 6 plus negative 25, which is a negative 19. Then I have negative 2 times 6 plus 1 times 1, which is negative 12 plus 1, negative 11. And lastly, for row 2, column 2 entry, I have negative 2 times negative 2, which is a positive 4, plus 1 times negative 5, which is a negative 5. So 4 plus negative 5 is a negative 1. So my solution in number 4, negative 13, negative 19, negative 11, negative 1. Now for number 5, we have a 1, 2, 3 by 2 matrix, and we're going to be multiplying that by a 1, 2 by 1, 2, a 2 by 2 matrix. Can we compute this multiplication? Yes, because the number of columns in the first matrix is equal to the number of rows in the second matrix. 2 equals 2. Check. But what's the size of that resulting matrix? That's going to be the number of rows in the first, 3, by the number of columns in the second, 2. So a resulting matrix is going to be a 3 by 2 matrix. So let's complete the dot product, taking row 1 and dotting it with column 1 of the other matrix. So row 1 of the first matrix, dot it with column 1 of the second matrix. That's going to be 0 times negative 4 plus 5 times negative 2. Now, finishing out that first row, I'm going to dot the first row of my first matrix with the second column of my second matrix. So 0, 5, dot it with that second column in my second matrix for negative 4. I'll have 0 times 4 plus 5 times negative 4. Now, I'll move on to my second row. So dotting my second row of my first matrix with the column 1 in my second matrix, that's going to be negative 3 times negative 4 plus 1 times negative 2, working left to right and top to bottom. Negative 3 times negative 4, the first numbers, added to 1 times negative 2, the second numbers. So using that same idea, now we're going to dot the second row with our second column. So negative 3 will get multiplied to 4 because those are the first numbers working left to right and top to bottom. Negative 3 times 4 plus 1 times negative 4. So if you ever get confused, just think work left to right in the row, top to bottom in the column. Now we're on to the third row. So negative 5, 1, and we'll dot that with the first column, negative 4, negative 2. So negative 5 times negative 4, and we'll add that to 1 times negative 2. And then finally, dotting the third row of our first matrix with the second column of our second matrix. That's negative 5 times 4 plus 1 times negative 4. Now all I have to do is simplify to get my matrix. So I have 0 times 4, which is 0, plus 5 times negative 2, which is a negative 10. 0 plus negative 10 is negative 10. Then I have 0 plus 5 times negative 4, which is plus a negative 20. So that's going to be negative 20. And then we have negative 3 times negative 4, which is a positive 12, and we're adding that to a negative 2, so subtracting 2. 12 minus 2 gives us a positive 10. And then we have negative 3 times 4, which is a negative 12, and we're adding that to 1 times negative 4, which is a negative 4. Negative 12 minus 4 is going to be a negative 16. Then finally onto our last row, negative 5 times negative 4 is a positive 20, and we're adding that to 1 times negative 2, which is adding a negative 2, or just simply subtracting a positive 2. 20 minus 2 is 18. And then finally, negative 5 times 4, which is a negative 20, plus 1 times negative 4, which is a negative 4. Negative 20 minus 4 is negative 24. And that's our solution. Negative 10, negative 20, 10, negative 16, 18, negative 24. Let's move on to number 6. In number 6, can we multiply? I have a 2 by 3 multiplied by a 3 by 2. Yes, we can, because my 3's match up, and it's going to be a 2 by 2 matrix. So, taking the first row and dotting it with the first column will give me my entry in row 1, column 1. So, 5 times negative 4 will get added to 3 times negative 3 plus 5 times positive 3. So you see I worked left to right and top to bottom. 5 and negative 4, 3 and negative 3, and then 5 and positive 3. Now I'll do row 1, column 2's entry. So 5 times 2 plus 3 times 4 plus 5 times negative 5. 5, 3, 5, each multiplied respectively by 2, 4, negative 5, and then summed together. Now I've finished my first row, on to my second row. I'll dot that with my first column, negative 4, negative 3, 3. So that'll be 1 times negative 4 plus 5 times negative 3 plus 0 times 3. And then finally, for my last entry in this matrix, dotting the second row with the second column. That'll be 1 times 2 plus 5 times 4 plus 0 times negative 5. Now what's my result? Well, let's go ahead and add it up. It's a 2 by 2. First entry in the first row is going to be negative 20 plus negative 9 plus 15. So negative 29 plus 15 is going to be negative 14. Now for the second element, or second entry in the first row, 5 times 2, I have 10 plus 3 times 4, which is 12, plus 5 times negative 5, which is 25. 10 plus 12 is 22, plus negative 25 is going to be a negative 3. And if you're having trouble doing this mental math in your head, feel free to write out another step simplifying a little bit further. Now for the second row, column 1, I have negative 4 times 1, which is negative 4, plus 5 times negative 3, which is negative 15, plus 0. Negative 4 plus negative 15 plus 0 is negative 19. And then lastly, I have 1 times 2 plus 5 times 4 plus 0 times negative 5, which is 2 plus 20, which is a positive 22. Because this 0, adding 0 doesn't change the number. So for my solution, I have negative 14, negative 3, negative 19, positive 22. Now moving on to number 7, can I multiply? Well, I have a 3 by 1, and I'm multiplying that by a 1 by 2. So yes, indeed, because my 1's match. And the result is going to be a 3 by 2. So starting with that first row, just a negative 5, dot it with my first column, will be negative 5 times 3. And then first row, second column will be negative 5 times negative 1. Now, working on my second row, I'll do second row with first column. That's going to be 6 times 3. And then I'll do second row with second column. That's going to be 6 times negative 1. And then lastly, for my third row, that's 0. Dot it with my first column. In my second matrix, that's 0 times 3. And then I'll do the same thing, dotting 0 with negative 1 for 0 times negative 1. And you can see that I will indeed get a 3 by 2. Let's finish out the math. Negative 5 times 3 is negative 15. Negative 5 times negative 1 is a positive 5. 6 times 3 is 18. 6 times negative 1 is negative 6. 0 times 3 is 0. 0 times negative 1 is 0. So my solution in number 7 is, if I'm reading by rows, negative 15, 5, 18, negative 6, 0, 0. Or if I want to read by columns, reading straight down, negative 15, 18, 0, 5, negative 6, 0. Let's move on to the last number on this page, number 8. So the first question we should always ask ourselves is, can we multiply these? So I have a 2 by 3 matrix, and I'm going to be multiplying that by a 2 by 3 matrix. You know what my answer is? Undefined. And we're done. This is probably the easiest problem on this sheet because the number of columns of my first matrix does not match the number of rows in my second matrix. I cannot multiply these together. My answer is simply undefined. So that was a quick one. Let's move on to the second page. So in number 9, can I multiply? Yes, because I have a 3 by 2 multiplied by a 2 by 2. The 2's match. So my result is going to be a 3 by 2. Now, in order to save a little bit of time on this video, feel free to continue writing out each of the steps. But I'm going to start doing the dot product in my head partially. So for row 1, column 1, that'll be 3 times negative 1, which is a negative 3, plus negative 1 times 5, which is a negative 5. So not much different than before. I'm just doing some of the math out as I go along. Now, row 1 by column 2, that's going to be 3 times 6, which is 18, plus negative 1 times 4, which is negative 4. Now, time for my second row. Negative 3, 6. I'll dot that first with negative 1, 5. So negative 3 times negative 1 is going to be a positive 3, and I'll add that to 6 times 5, which is 30. Now, for the second row, second column, negative 3 times 6 is a negative 18, and I'll add that to 6 times 4, which is 24. And then lastly, my third row, I'll dot that with my first column, so I'll get negative 6 times negative 1, which is going to be a positive 6, plus negative 6 times 5, which is negative 30. And then, lastly, that third row, dot it with the second column of the other matrix. 6 times negative 6 is negative 36, plus negative 6 times 4, which is negative 24. And remember, adding a negative is the same as subtracting a positive, so however you want to think about this is perfectly fine. Now, let's just simplify. Negative 3 plus negative 5 is a negative 8. 18 plus negative 4, or 18 minus 4, is 14. 3 plus 30 is 33. Negative 18 plus 24 is positive 6. 6 plus negative 30 is negative 24. And negative 36 plus negative 24 is negative 60. And that's my solution in number 9. Negative 8, 14, 33, 6, negative 24, 60. Moving on to number 10, I have a 2 by 2, and I'm multiplying that by a 2 by 1, so the result is going to be a 2 by 1. First row, dot it with the first column. That's going to be 5 times negative 4, which is negative 20, plus 4 times 3, which is 12. And then I'll dot my second row with that first column. 2 times negative 4 is negative 8, plus negative 1 times 3 is negative 3. So the result of this matrix, negative 20 plus 12, is going to be negative 8. Negative 8 plus negative 3 is negative 11. So negative 8, negative 11 is my solution for number 10. In number 11, I have a lot bigger matrix for that first one, but let's see. It's a 1, 2, 3, 4 by 1, 2, 3, 3. So I have a 4 by 3, and I'm multiplying that by a 1, 2, 3, 3 by 1, 2, 2. So a 4 by 3 multiplied by a 3 by 2, my 3's match. So the result is going to be a 4 by 2. So stick with me as we do out this math. 4 rows, 2 columns. I'll give myself a little bit of extra space in this one. I'm going to take row 1 and dot it with column. So negative 1 times 6 is a negative 6, plus 1 times 5, which is 5, plus negative 1 times 6, which is negative 6. And now I'm going to take the first row, second column. Negative 1 times 5 is negative 5, plus 1 times negative 6 is negative 6, plus negative 1 times 0, which is 0. So let's go ahead and switch this up, doing out that first row. Negative 6 plus 5 plus negative 6 is going to be negative 12 plus 5, which is negative 7. And negative 5 plus negative 6 plus 0 is negative 11. So continuing on, let's now look at our second row. So dotting the row with that first column, I'll have 5 times 6, which is 30, plus 2 times 5, which is 10, plus negative 5 times 6, which is a negative 30. 30 plus 10 plus negative 30 is going to give me a positive 10. And then for the second row, second column, I have 5 times 5, which is 25, plus 2 times negative 6, which is negative 12, plus 0 times negative 5, which is 0. 25 minus 12 is going to be a positive 13. So now I'm done with that second row. Moving on to the third row, 6, negative 5, 1. I'll dot that with 6, 5, 6. 6 times 6 is 36, plus negative 5 times 5 is negative 25, plus 1 times 6, which is 6. 36 minus 25 is going to be 11, and then plus 6 will give me 17. And then dotting that third row with the second column, 6 times 5 is 30, plus negative 5 times negative 6, which is a positive 30, and then 1 times 0, which is 0. 30 plus 30, that's going to be 60. And now finally, that last row, dotting it with the first column at the start, we'll have 6 times negative 5, or negative 5 times 6, which is negative 30. I'll add that to 6 times 5, which is 30, and then I'll add that to 6 times 0, which is 0. negative 30 plus 0 is 0. And then dotting that first row, dotting that last row with the second column, 5 times negative 5, or negative 5 times 5, is negative 25, plus 6 times negative 6 is negative 36, and that will get added to 0 times 0, which is 0. Negative 25 plus negative 36 is going to be a negative 61. So my solution in number 11, negative 7, negative 11, 10, 13, 17, 60, 0, negative 61. Now moving on to number 12, I have a 4 by 2 multiplied by a 2 by 3. This is probably going to be our biggest matrix yet. I can multiply it because the 2's match, and the result is going to be a 4 by 3. So, starting with the first row, I'll dot that with the first column, second column, and then third column, getting each of my separate entries. So negative 2 times 2 is negative 4, plus negative 6 times negative 2 is a positive 12. And then, now onto my second column. Negative 2 times negative 2 is a positive 4, plus negative 6 times 0, which is 0. And now, finally, onto that third column. Negative 2 times 2 is a negative 4, plus negative 6 times negative 3, which is a positive 18. Negative 4 plus 12 is a positive 8. 4 plus 0 is 4. Negative 4 plus 18 is a positive 14. Now, on to that second row. And again, dotting it with the first column. Negative 4 times 2 is negative 8, plus 3 times negative 2, which is negative 6. And then, second column, negative 4 times negative 2 is a positive 8, plus 3 times 0, which is 0. And then finally, the last column, 2 times negative 4 is negative 8, plus 3 times negative 3, which is a negative 9. So negative 8 plus negative 6 is a negative 14. 8 plus 0 is 8. And negative 8 plus negative 9 is a negative 17. So that's our second row. 2 more rows to go. 5, 0. Dotting that with the first column. 5 times 2 is 10. Plus 0 times negative 2 is 0. Then dotting that with the second column. 5 times negative 2 is negative 10. Plus 0 times 0 is 0. And then finally that third column. 5 times 2 is 10. Plus 0 times negative 3 is 0. So, the 0 made it a little bit easier. 10 plus 0 is 10. Negative 10 plus 0 is negative 10. 10 plus 0 is positive 10. Lastly, on to that last row. 4, negative 6, dot it with 2, negative 2. 4 times 2 is 8. Plus negative 6 times negative 2 is a positive 12. And then 4 times negative 2 is negative 8. Plus negative 6 times 0 is 0. And then lastly, 4 times 2 is 8. Plus negative 6 times negative 3 is a positive 18. Now, finishing out that math, 8 plus 12 is 20. Negative 8 plus 0 is negative 8. And 8 plus 18 is 26. So my matrix in 12 is 8, 4, 14, negative 14, 8, negative 17, 10, negative 10, 10, 20, negative 8, 26. That's my solution for number 12. Now on to some smaller matrices, but they're switching things up because now we have a variable. So I'm going to continue to write this all out so you can see. This is a 1 by 2, and we're multiplying it by a 2 by 2. So, because the columns of the first match the number of rows in the second, we're going to have a 1 by 2 matrix in the end. So, taking the first row and dotting it with the first column, that's going to be 2 times negative 5u plus negative 5v times 0. And now, dotting that first row with the second column, that's going to be 2 times negative v plus negative 5v times 6. So you can see I have a 1 by 2 matrix. Let's go ahead and finish this out. 2 times negative 5 times u is going to be negative 10u, and that's going to be added to 0. So negative 10u, and then for my second part, I have 2 times negative v, which is a negative 2v, plus negative 5v times 6, which is a negative 30v. Negative 2 plus negative 30, because I have like terms, is going to be a negative 32v. So my solution in number 13 is negative 10u, negative 32v. And lastly, for this set of directions, number 14. I have a 2 by 2 multiplied by a 2 by 2, so my result is going to be a 2 by 2. So, doing out the math, first row, dot it with the first column, I'll have negative 4 times negative 4x plus negative y times 2y. And now, first row, dot it with the second column, that's going to be negative 4 times 0 plus negative y times negative 5. And then for my second row, taking that second row, dotting it with the first column, that's going to be a negative 2x times a negative 4x, and I'll be adding that to negative 4 times 2y. And now for my second row, second column entry, negative 2x will get multiplied by 0, and then I'll add that to negative 4 times negative 5. So now all I have to do is simplify. For my first entry in row 1, column 1, I have negative 4 times negative 4x, which is going to be 16x, and I'll be adding that to negative y times 2y, which is going to be negative 2y squared. So as opposed to adding, I'll just subtract 2y squared. And then I have negative 4 times 0 plus negative y times negative 5, which negative 4 times 0 is 0. Negative y times 5y is a positive 5y. And then for row 2, column 1, negative 2x times negative 4x is going to be an 8x squared, and then I'll be adding that to negative 4 times 2y, which is a negative 8y, but as opposed to adding a negative, I'll subtract a positive 8y. And then lastly, I have negative 2x times 0 plus negative 4 times negative 5, which is going to be a positive 20. So 16x minus 2y squared, 5y, 8x squared minus 8y, and 20 are the entries in my matrix for number 14. Moving on to some critical thinking questions, it says write an example of matrix multiplication that is undefined. Well, in order to be undefined, so this is pretty easy. We can do a 2 by 2 and multiply that by a 3 by 2 because the 3 and 2 do not equal each other. This answer would be undefined. So just pick a 2 by 2 matrix. Let's say 1, 2, 3, 4. Or you could even do 1, 3, 2, 4 or 5,000, 2,000, 102. Doesn't matter, just fill it in. And then try to multiply that by a 3 by 2, so we need 3 rows and 2 columns. So I'll do 1, 2, 3, 4, 5, 6. Because the number of columns in my first matrix does not match the number of rows in my second matrix, this is undefined. And lastly, number 16, in the expression A times B, if A is a 3 by 5 matrix, then what could be the dimensions of B? So if A is a 3 by 5 matrix, and we're multiplying that by some other matrix, well, we know for a fact that the columns in the first matrix, so our number 5, has to match, so we need to have 5 rows in matrix B. But the columns, well, they can be whatever we want them to be. 1 would give us a 3 by 1 matrix as the result. 2 would give us a 3 by 2 matrix as the result. We could have 5 again, or maybe even 6, which would give us a 3 by 6 matrix. We could do a 3 by 5 matrix multiplied by a 5 by 10 matrix, which would result in a 3 by 10 matrix. So really, as long as we have 5 rows in matrix B, the columns can be anything. And that's the final solution on this worksheet. If you have any questions, leave them in the comments below. If you want more ways to support me, click that Patreon link and find out more. And as always, don't forget to like, subscribe, and share.